What about you? And we're back on the bench. So there's no car repair in this video, but we'll show you a wee bit more about diesel injectors towards the end of the video, and we'll do a wee bit of mucking about here on the bench. There's a few things out. So first off, we've got a wee piezo disc here. It's out in the bench, and that's similar to what's in that first look pressure pulse sensor, or delta pressure sensor, some people like to call them. And there's it there in the scope. So we'll just give that a wee crush there. Just move you up a bit. Give that a wee bit of a tap, and we can see the changes on the scope there. So I'll maybe show you that as a voltage. So that's it in numbers as well there, so we can see the creating a voltage there. What's that going up to? About 7 volts there. So that's a pulse sensor. So whenever I press on the crystal, I'm compressing the crystal and it's creating a voltage. So the opposite is the case when it comes to these piezo injectors. So when you put a voltage across it or a current through it, it moves. It creates a movement. So instead of me doing the mechanical movement and creating a voltage, you put a voltage into it or a current through it, and it creates a mechanical movement. So that movement it's very minute. It's microns of movement, and what that does then is it acts on the nozzle indirectly. It opens it indirectly. Because it uses a hydraulic action. It's a bit like, you know, your trolley jack, that you move a small piston and it creates a larger movement. So and this one here, this is a Denso injector. It's out of a Toyota, and we can see this what they refer to as the stack. So I read somewhere there's about 400 of these discs in there, in a stack. That's what they call a stack. So if you imagine that 400 of those wee boys there, all one on top of another one. So that's the piezo stack there. So I have another video on the channel there where I put current through this and actually get it to move, and we can see the movement on the tip on the dial gauge. But we're not going to do that in this one. So to relate that to, I can relate that to this. This is an LED down here in the bench. So I'll just get you in that. So there's a wee LED. And so if you put a voltage across that, the same sort of thing happens with this. If you put a current through that, you get the thing lights up. Now, if you do it the other way around, and you put light into it, so instead of it emitting light going out, light emitting, you put light into it, you actually get a current flowing, and that is a solar cell. And then, now, if I put light onto that, you won't see it. It isn't designed to do that, but it's the same principle. So it's the same principle as piezos. You put a mechanical energy onto it, you get a current flowing, and similarly, if you put current into it, you get movement out of it, you get a mechanical movement. And same with the LED. So moving over from that, we'll have these wee two boys here on the bench, and I found these interesting. This is pure salt. This is sodium chloride in a crystalline formation. This is naturally occurring, and this came out of a local salt mine that's in my town in Carrickfergus in Northern Ireland. It's a mining company called Irish Salt Mines and Exploration Limited, and they dig out tons and tons of salt every year. But it's not salt that you put on your chips, it's salt that you put on the road in the wintertime. And it comes out and it's mixed with clay and soil. So the brown sort of residue that you get all over your car, messes up your car, is the clay that's in the salt, and they just dig away at it at the rock face, and grind it down, and that out it goes. That's all they do to it. They don't wash it or they don't do anything like that because it would dissolve it. So that salt, the tons and tons of salt, is exported to the eastern seaboard of the United States, New York, Canada, Scandinavia, and Great Britain for use on the roads, and that comes from under my feet. And I was lucky enough to get a tour of that mine, and I put a few of these in my pocket. Now these are formed when the seam of salt is there's a lot of water about, or it's partially flooded or something, and the water evaporates off, and it leaves it in this exact square sort of crystalline structure here. So I thought to myself, this is a piece of salt with a crystalline structure. I wonder, can I squeeze the molecules in this and see if we can get a piezoelectric effect out of this naturally occurring straight out of the ground. Now, there is a piezo, people do make piezos. It's a thing called Rochelle salt, and they make salt crystals by boiling down baking soda and tartar, I think it is. They make it into potassium carbonate, I think it is, and it's got good piezoelectric qualities because of the crystalline structure. But this is straight out of the ground. I haven't done anything to this at all. This is great for if you have a wee dish of these and put it in your house. If it acts as a bit of a dehumidifier, because that sucks in all the moisture that there is in the air. So I have that in the vase. I have one of them wee crystals there in the vase in a wee clamp. I'll move you over to here, and there's it there. So we're going to do a wee bit of mucking about with this. So I have a piece of that salt crystal in this plastic clamp. It's just held in the vase there, and a couple of bits of tin foil to use as an electrode, and have it connected to the scope. So I'll get you over to that. I'll probably have to knock this down a bit because this is very minute. What will come out of this? So as I say, I haven't done anything to this. I've just been mucking about with it. And there's a wee bit of activity there, very slight. And you may think, well, that's just me knocking it. That's all it's saying there. But we're going to see if we can get a voltage out of this piece of salt. So just show you this tool here that I was actually given by a rep who this is for this is a wee promotional thing. I don't know where you can buy this or not, but this is from clearly Philips there, and their name's plastered all over it there. So what we'll have is a wee mirror, and that extends there. I can't. It's very nice indeed. And this thing here comes out with a wee holder, and it's like a forceps for surgery or something. So what this is for taking bulbs out. This is what this is designed for. This is Philips from the lamp manufacturer, the bulb manufacturer, and there's a wee ratchety thing here, and that holds. So if you put your finger in this, and that, it bends and puts a hell of that's a fair old squeeze in my finger there. And so the idea of that is for pulling bulbs out. So you catch the bulb there, and you get ratchet into place, and that's held there. I'm not putting any force in that, so you can give it a good tug. I'm sure you've all been in that situation before. So it would be, that's a good wee tool out there. I think they should market that. Obviously make it like so. But that was it's like a promotional item that I was given that for free. So it was awful nice. And so we plug for Philips there. We've connected this to the voltmeter. We can see a minus in millivolts there. So it's a bit of a ghost voltage there, and we're going to put our forceps on the crystal here and give it a bit of a squeeze. Hopefully it doesn't break. Now we can see the change happening. It's going to positive there, and it's just rising up. So it's went from the negative there to the positive. So that'll have generated a volt there. So it was minus 60 or there or something like that. And that's starting to come down again. So we'll take that off again. It's back down to the minus again. So we can see that it's generating about a volt, maybe a wee bit more, by giving that a wee bit of a squeeze. What we're going to also do is get this thing to act as a capacitor, and get a bit of charge into it. So that's what it basically is. So I'm going to put 100 volts in it. There we go. Charge that up a wee bit. Let's see what we've got. Over limit. So give that a wee squeeze here. Let's see if we can get that down. There we go. That's it discharging. Right. Moving the molecules a bit. So there we go, just a wee bit of mucking about on that. So that's it, acting as a capacitor there by putting a bit of a charge in it. I've got over 500 millivolts into it. And give it a bit of a squeeze and we'll see a bit of activity. It's very minuscule, it's very minute, it is all over the place because there will be a ghost voltage here. So, for example, if I take these leads off completely and just zero right, there's at zero, so we're not connected at all. We do get a wee bit of a floating voltage there. Well, it's not very much. So if I connect that on again, so there'll still be a wee bit of charge in that. Connect it on again. It's raising a wee bit there by itself. Let's do that again, give it a bit of a squeeze again. So it's going the other direction. So very minuscule, but you can see a wee bit of activity there, and we can charge it up. What we'll maybe do actually is we'll charge it up in the other direction. Reverse the leads. Stick 100 volts into it. Press the button, that would help. There we go. Let's see what she's reading now. It's mainly like that. Or a wee salt crystal. So it's way in the negative now. So we got current to flow in the opposite direction. And just holding that charge a wee bit. Give her another wee squeeze. That's it, bring it way down. So there we go. So what does that got to do with diesel injectors? Well, I'm going to show you a wee clip here, and we'll maybe relate that. So this is our piezo stack. That's a piezo, and anybody that works in cars know that these give a bit of bother. They are troublesome, and they're very expensive. And the reason why this is a solenoid injector, so this is just a coil in it, and it just energizes and moves a pin up and down. So this was out years and years ago, and it wasn't really accurate enough to give post injection for DPF cleaning and stuff like that. So it's not really accurate enough. These here are super duper accurate. These only move like a micron of movement, and that can be controlled, so it can be held open for longer by keeping it energized and stuff like that. But they've proved to be pretty expensive and pretty unreliable. So they've actually went back to solenoid, but with a bit of a difference. They've made these solenoid injectors more accurate, or as accurate as these in their injection times and number of injections. So, or injection duration as well. So, a wee clip here, and I'll just show you what the new solenoid injectors look like on the car. So this is a 1.6 TDI in the VAG range, and this is a 2015 car. So the latest type of injectors are actually back to solenoid injectors. They're going away from the piezo, and you can visually make out and see the new type here. It's got a wee bird's nest type configuration on them there. You can just see it poking out there. So they're actually solenoid injectors. They're not piezo at all. So this is what's called a low mass solenoid injector. It's low mass, and that's what they're called. So it's they're far more accurate than the original solenoid injectors, but these are solenoid injectors. They are not piezo at all. The thing to note maybe with these as well is a very, very big return line on them. So these things, the way they operate with a wee valve bouncing up and down, and it actually passes fuel. So it's not just back leak that goes down there. These back leak lines, I guess you want to call them, but it's not just back leak. They will naturally put diesel back out under normal circumstances. So even just sitting here, if the fuel pump runs or if there's any sort of pressure, that will back out. So there's a larger return line, a larger diameter return line, and the hole in there. Get my hand out of the way. The hole in the back leak pipe goes into is larger diameter. So your wee back leak pipe kits for the ordinary Bosch injectors, this is a wee bit bigger and they won't fit. So you need to have some sort of different type of adapter for doing it. But you can still do a back leak test, but there's an awful lot more flow on that. So anyway, that's how you know that. That's how you know that's the new style. They're solenoid. They are not piezo. So that's how you can identify those new type low mass solenoid injectors. So that's our wee Northern Ireland cubic salt crystal that is out of the main, that ends up on your road and ends up all over the bottom of your car, making a complete mess. So you've us to thank for that. And anyway, that's the end of this video. Maybe got a wee bit something out of that, and I thought that was a wee bit of interest, doing that wee experiment there. So hope you enjoyed the video. Maybe you got something out of it, as I said, and many thanks for watching as ever, and all the best, and bye bye.